Welcome back in a new video. In this, we will discuss about email spam classification with logistic regression. These are all the topics we will cover in this video. So, hello data scientists. Today, we are building something you use every single day, a spam filter. We are going to teach a computer to look at an email and immediately decide, is this a helpful message or it just a junk mail trying to scam me? We will be using special machine learning tools called logistic regression. This project shows you how powerful coding can be in the real world. Let's dive into become a spam fighting heroes. When we predict house prices, the answer was a number like $4,500 and so on. But with a spam filter, the answer is a simple choice. We call this classification. The model has to choose one of the two classes. Ham, which means not spam, which we will call 0, or spam, which can be called as 1. Since we only use a 0 or a 1, our straight line model, linear regression, we wouldn't quite work. We need something better for clear-cut choices. This is the model how logistic regression works. You can see here there are choices. This is the first data or the element. There are the choices 0 or 1, yes or no, like this. Imagine if we tried to use the simple straight line we used before. Sometimes the prediction might be the number like 10 or even 5. What does a price or negative $5 mean for an email? It makes no sense. For classification, we need a model that always gives you an answer that is easy to interpret, especially an answer that looks like a probability, something between 0% to 100%. Moving forward, that's why we use logistic regression. This is how the logistic regression graph looks like. It is a useful mathematical tool called sigmoid function. This is the sigmoid function, which creates a perfect S-shaped curve. This curve is to take the model's raw score and squeeze it down to a value that is always between 0 and 1. This final value is the probability that the email is a spam. If the probability crosses a certain threshold, say 50%, the model say, yes, that's a spam. So for this, step 1, text to the number. The single biggest challenge with text data is that computers only understand numbers. So we have to translate. This is the first step in the neural natural language processing NLP. We take the text of the email and convert it into a numerical format. We do this by creating a special code where every word gets a number and we start counting. This process turns words like free and win into numerical features the model can accept and learns from it. Step 2, the feature matrix. Now we organize those numbers into a feature matrix. Imagine a giant spreadsheet. Every single unique word for all your emails become a column headers. Then for each email, the cell shows the count of how many times the word appeared. This process is often called bag of words. The key idea is that the frequency of the words, like urgent or the password, becomes important and in the numerical data the model uses to judge. And step 3, the last, the training of the model. Just like before, we train the model by feeding it our numerical features matrix along with the correct answers, the labels 0 or 1. The logistic regression made then learns the specific weight for each single word. A word like unsubscribe will get a very high weight because it appears a lot in spam. A word like colleges would get a low weight. It's finding the best S curve that uses those weights to cleanly separate the spam from the ham. Finally, a brand new email arrives. The system initially converts the new email into its list of numbers or the numerical word counts. It plugs the numbers into a formula it just learned. The model calculates its final score and pushes it through the S curve. If the result is say 0.95, the model say that's a 95% chance of being spam and instantly sends it to your junk folder. This is the core of how every model email client protects you. You can see here how the data is going to the model and then it is predicting whether it's happy or sad like this. Before moving forward, let's create our model and see how it works. Simply start Jupyter Notebook. I'm creating a new folder here. Sorry, a new file here. Uh, Naming it as spam uh, email, spam email. Just rename it spam email. Step first, import useful tools. First, import pandas as PD. I'm simply importing the pandas library as PD. Then we will use sklearn library. From sklearn library, we have to use use, or we need some model and the functions. So for this, use sklearn from sklearn dot model selection. We will import the test and train split. We use this to split our data into testing and training. Second, we will use from sklearn dot feature matrix, feature extraction dot text count vectorizer. We simply imported count vectorizer from the sklearn feature extraction. It turns the words into numbers. We want numbers so we can train our model easily and predict our new data. And then from sklearn dot linear underscore model import logistic regression. This is the model we are using for the classification, the logistic regression. And the last thing from sklearn dot matrices import accuracy score to check how well our model performed. Simply run this, and here you can see all these are run. Our code has no error. Step 2, step 2 is create and prepare data. We will use a data. We will create a simple data here because we have to learn how this works. After learning, we will use any data from websites like Kaggle or anything else, or we can use a real-time data also. So before working on that, we will use self-made data. Simply name as data. We are creating a dictionary here, and first thing is label. Label, and it's array, simple span, uh, span. I'm randomly generating that data, so you can change if you want. And these are 1, 2, 3, 4, 5, 6, 7. We created the 7 here. I think 10 are enough for this. And the last one is also. Let's go for the message. Here's the list of the array. We will messages first is have and call me tonight. And second is for spam. Here win the free prize. I'm just creating my data according to this label. So it's not like that I am using any random value or like this. For ham, I can say the call me tonight is a true value or it's can be a real mail, not a fake mail. So that's why it's in ham. And second for spam, winning a free prize now, it can be a spam message. So like this. See you at 4 p.m. It can be correct as there is third value is ham and fourth one is we can say yeah, so cash flow. It can be spam. I got another spam idea. You have $1. Before that spam, there is an ham. We will say like can can we reschedule? It's for anything, for meeting or for test. It's for anything. And then it's a spam. Then call again the ham project update. Here we attach the project updates. Also a question mark. Yeah, sorry, comma. And with the second one, two, three, 4, 5, 6, 7. And it's message for spam. It's like free gifts for you. And here's the ninth one. Thanks for the notes. I think the last is also have. Okay, so wait, where should we meet? So this is our data set on which we will work today. We have two columns, the label column and the message column. In the label column, we have divided our data into two particular parts, the ham and the spam. Is the email is a correct or a valid email, ham or anything spam, just a fraud email. We use some messages for this. Moving forward, first we have to create a data frame for this. Data frame. And we are using data, this data set only. Just run it. Okay, this is how it runs. Simply print it. Here you can see the labels. This is the data set, and there are two columns, label and the messages. Here you can see ham and spam. This divided into two particular classifications or two particular classes. Ham, call me tonight, or the spam, win a free prize now. Ham, see you at 4 o'clock. It's like that. We have total 10 elements, 0 to 9. Now we will label the data frame or the ham and spam label. We will convert this, or we will simply use the map and map ham as a 0 and spam as 1. Like this, data frame if, and we are using label. I'm creating a new variable as we are using label num equals to df dot label dot map, simply curly brackets, and in this ham for 0 and spam for 1. This is how we mapped ham as 0 and spam as 1. Simply run this. There is no error. So moving forward, we okay, just I will write in this column only x. We will providing a variable to each columns of our data for the label and the message. For the label, we use x, and the message we use y. Df. As you can see here, we just converted our label into label number. That's why we use label num as we have to, or we want the label like ham or spam as 0 or 1 to easily train our model and predict the data. So before that, I will use X as message. It's same. That's okay. We will give X as the second column message and Y as the first column. Label name, num, not name. Simply run this, and moving forward to our step 3. Step 3. This is splitting the data into test and train data sets. So simply split data into test, profit, and train data sets. For this, we will use the test train test split. So here, simply use x train. We are creating variables here. X train, x test. We need four variables. Two for training the model, one for testing the model, and one for the prediction. Y train, Y test. Here we use train, test, split. And this I will simply write here x, y. X and Y are these. The X, the second column of the dataset, the message, and the Y, the first column of the dataset, label, but in the form of 0 and 1. Ham and spam in the form of 0 and 1. And third thing is test size. We will make here how big we want our dataset as for the testing part. We will make as 0.3 as it's for 30% of our data will use for the testing part, and the remaining 70% will use to train the model. And now for random state, a random state from which your model will start working. Simply print here you can see messages for training. I will show you how many dataset or we are using for training our model. Simply length of extreme. Oh, sorry, I forgot to write here as F. Now it will work. Simply copying this to save the time. I am simply copying this, copy and paste here. And this is for the training and for the test. Was test testing part. Here now you can see we use 10 of our data. Total elements in our data set are 10. Using this, you can see here, I put that test size as 0.3, the 30% of our data set as used for the test. So total messages using for the test are 3. Total messages are these, total 10 messages. From these 10 messages, 3 are used for the testing part, and remaining 7 are used for the training part, training the model. So after training part, then Three messages are used for the testing part. This is a small data set, so you can see here it's simply showing 703. If it's large, then the numbers may be changed. May it absolutely change. Let's go. For step 4, step 4, simply comment this. Step 4 is text to number. This is the part of the vectorization where we use the vectorization for converting the dataset or converting the text values or the text data into numbers. So we can easily train our model and use for the predictions. Vectorizer, we create a variable name as vectorizer, and for this the count vector, just a second, count vectorize setting vectorizer. Here you can see now we are using this one, the count vectorizer, for extracting or for converting the text values into the number. So first we will we will convert the training dataset into a number x test. Sorry. First we are using the train x train underscore vector and just creating a new variable x train vector. Okay. For this vectorizer dot transform, and in bracket we will use the x train dataset only. But for this, before converting the training message into a word of matrix, we have to teach the vectorizer the unique words for the training set. And for this, we will use dot fit before the transformation here, before the transform function. And now simply we will do the same for the test data. Test vector. uh, test vector as vectorizer dot transform. We only we have to only use here the transform function as we uses we just give a unique word for the training dataset earlier. So we don't have to use the dot fit here again. Transform as train. Sorry, test. Now simply print. We will use the print function for this print sample of numerical features for one message. Vector. And for this, simply print string vector dot to array. And in this, the zero, oh, it's a function. Before this, we use the bracket. And one more thing, before printing this, print use the print method again. It's vocabulary. It's all right. Vocabulary size, the unique words, length of vectorizer depth feature dot names. Just a second. What I have to use. And for out, this is the function out function, and this is the it shows the tense representation of the first training message features. Here you can see it's showing an error. I think series object or something is not right here. Just a second, I will fix this. Oh, for this we simply have to add a parenthesis in last this. So here you can see the training data into array form, the vectors, or we converted the data into number form. Here you can see the data into number formats like 001, 0000001, 0. It's like this. These are numerical features for one message. And you can see there are total of 10 messages. And this is from any one of it, like this. It converted the call me tonight into a series of numbers like this 01010101, like this. Okay, here I by mistakenly searched that. Moving forward to our step fifth. So step 5, train the logistic regression model. Simply tra training of the model. Simply train the model. Okay, now we will train the model. First, we will use the simple model as the variable, and we will provide it the logistic regression. Logistic regression. This is we initialize the logistic regression model. Now training of the model. Model dot fit, and for this we use x underscore train and y underscore train. Oh, just wait. We will use this function only as we have already converted our label column or the second column for the y into the 0 and 1, but now we just converted our message column into the array of the numbers. So for this we will use this variable to train our model. Here we go. Okay, just bracket. And now we run this. You can see here our model is trained. Simply there is no error. Our code runs smoothly. Now it's time for step 6. Oh, just second. 6. Step 6 is the making the prediction. Is the making the prediction. We will use a variable predict, and for this model dot predict, and we are using this for the training vector, the training, sorry, the testing data set. We already use the training data set to train the model, so we will use that testing data set for testing the model. The testing, uh, the testing vector, the vector form of the message column just for the testing, and then simply check for accuracy. For this, we will use accuracy score by test and y print. As we will use to check the accuracy, we will use the testing dataset which we make earlier. This is the testing dataset and the prediction. This is the y predict. Oh, sorry, just change the variable, the prediction. We will use these two values for checking the accuracy and then simply print different model accuracy of score. This accuracy multiplied by 100 to convert this into percentage form. That's why I'm using this formula to multiplying it. And oh, just a second. Here's the here we go. And second thing, print simply predicting the value. Model accuracy. Here you can see the model accuracy is 33.33 percentage. It's almost the one third. And the prediction is 0, 0, and 0. Here you can see. Okay. So this is the prediction for three values. As we use, as we used, where it is. Just a second here. You can see we use three messages for the testing part. So that's why there are three values, 0, 0, and 0. These are all the value for ham. So this showing the our training or sorry, our testing data set is not a spam message. So after this, it's time for our seventh step, the final test. Step 7, final. Oh, I just wrote final. Final test. Prediction of predicting a new message. So for this, we simply create a function def check spam. Before this, I will show you how this works. How, just a second, how logistic regression works. What is that? World's Octopus Day. Okay, logistic regression. From the images, I will show you how it works. Okay, as I shown you earlier, that this is the how it, graph of logistic regression. So I think this is a good example. Logistic regression. It simply divides, or it's not the straight line as the linear regression, as the line goes straight, but in logistic regression, it divides the dataset into different classes. Like you can see here, there is a green ball or green dot part, and here's the blue dot part. And the line simply a S-type curve, smooth curve divides both the line, sorry, both the dataset. There are some points that lies on the line, and I will show you some more examples. Here you can see these are all the data points. And if the data, one thing I just noticed here, if the data sets are on the extreme edges, you can see here just the 0 and 1, then the classification is like that. Here's the 0, the data set all lies on the 0 point, and the data set all lies on the 1, 0 and 1. And is there any other example? Here you can see it's it's not the linear regression. This is a good one. I'll show you. It's not the linear regression, as this line is straight, but this divided the dataset into two parts, green and red. But in linear regression, all the datasets are closer to the line, or you can say that the line which is in between or created or generated in the linear regression is just the line closest to each data points. Here you can see the difference. This is logistic regression. This is one class. This is second. And here it's the linear regression. It's the minimum distance line from each data point. This is the best fit line. Okay, we will go back to our topic. So here you can see we just simply imported the data. Oh, sorry. We simply imported all the libraries we needed for this model, and then we used our own created data set. We have two columns and total 10 rows, and the columns are label and messages. And then we converted the data set into data frame. This is the data frame. Then we simply converted the label data or mapped the ham as 0 and spam as 1. Then in next part, we split the dataset into test and train dataset, 30% for testing part and 70% for training part. Then we convert the test to numbers. Oh, sorry, it's not test. It test to numbers. Okay. We converted the dataset, the this message column into numbers part. As earlier, we have converted the label part into numbers here, and the messages part we have converted here. And there you can see this is how it looks. A single message converted into a numerical format 0000100 like this. And then we trained our model and predict a model. Now we will use this model to predicting another message or another mail. We are simply creating a function and passing a message from this message vectorizer. We have created a variable message vectorizer, and for this vectorizer dot transform message. Here you can see, here's the same thing we have done here. We simply converted the given text message or text data into numbers. This line simply converts the new message using the same vectorizer as here the same vectorizer. It converts the text data into messages. Oh, sorry, text data into numbers. And then prediction. Model dot predict predict message vectorizer. Here you see. In now using this variable which converted our message, the given data into number and stored it in this variable, and we will use that variable for prediction or for predicting the new email. And then prediction, then for just simply I will write here only if prediction both are same. Sometimes there are spelling mistakes. If prediction is one, the result result equals to span, else result equals to n. Okay, and then it's simply print. Use the print function. Printing the message here. Prediction for this result. Okay, now simply Clear on this? We have created the function for checking our model. Is this working properly or not? We have seen here only how the model works, and this function now we will use some messages or some mails for this. What's that? Check some. Okay, let's check. Let's check. Let's again and again. Check spam. Good. Hey, let's grab for lunch next week. Okay, this is the first. Let's use check spam. Claim your free files and collect money now. This is another, and we will use one more. Check spam. Call no for a quick cash win. Simply run this and okay. Was just but not attribute predict. Just a second. Okay, I simply it's a typing mistake. Our model has predicted all this data like this only. It predicted as ham as it's not a spam message. It's simply the grabbing the lunch next week, and this is the message, and our dead model prediction is ham. So it's not a spam message. Okay, I think it's enough for today for learning how the logistic regression works. And we have trained our model, we have created our model, then we have trained our model. As here we use our predefined data set. You can simply go here and check for logistic regression, simply data set, and for Kaggle. You can see here there are many different types of data set for logistic regression. You can pick any one of from this and simply use that on this model only, and you can check how this model works by your own. So I think this is enough for today for the coding part. Let's move back to our presentation. Now, moving forward, congratulations, you did it. You have successfully grasped the basics of the text classification. You understand why we need logistic regression for a yes or no decision and how we use NLP to turn the words into numbers. These skills, classification, feature engineering, and training are the true building blocks of almost every cool thing in the data science. You are ready for more. Keep the learning momentum going. Thank you.